Hello everybody, welcome to my Intro to C++ workshop. Today I'm only gonna be going over like the basic things. This like mini course is used for people who want to get into programming or that they have like no idea where to start. So hopefully by the end of this presentation you'll be able to have like a good idea what programming is and what C++ does. And if you're more interested, then you can always like talk to me and I'll be able to direct you to better sources for your growth in case you decide that this is something that might be interesting on you. Okay, so a little bit of an overview for today's workshop is we're gonna go over the introduction of why C++, like why am I teaching this instead of like a different or simpler language like Python. We'll go a little bit in an overview about like the logic, flowcharts and algorithms, like how it's structured, how like a programmer should be able to think and derive a problem, and how we can convert that into like an algorithm and then the algorithm into code. We're also gonna go into like introduction of data types and variables. This is very important just to help visualize the data for like numbers or strings, depending if you want to do some type of mathematical operations or you want to just like read through a series of strings and text. That again, it goes into the arithmetic and logical operators to think like logically. The majority of like electrical engineers and mechanical will probably be able to recognize some of these logical operators. It's like the same with the circuitry, but instead we're utilizing it in code instead. And at the end, we're gonna go over like a few examples with like logical statements for like the if statements, switch cases, loops, and arrays, which are usually like the main tools that we use while coding C++ or in general with every language. Okay, so why is C++? C++ is an object-oriented language. What that means essentially is like it's built within classes. So let's just think about like a car and how a car is made of like doors, windows, an engine, etc. And each piece of the car has like a function that allows to make the car whole and operate into like one unit. So object-oriented is essentially the same thing with C++. We're able to do programs that builds into classes, and each class can operate like a different function that makes the entire program a lot more whole. And this is very powerful because not a lot of languages do this, and if you can get very good at it and you can make a very robust architecture within the language. Another thing is memory management. Memory management is actually hugely important when it comes to coding. If you don't know how to manage memory pretty well, then it can eat up all of your RAM, and then it slows down your computer, or it can just crash the entire program altogether. So C++ is very good at this, and it's actually one of the main reasons why a lot of like compilers and programs and a lot of projects like really use it within the companies. Again, like companies use a lot of C++, or at least a variation of it, specifically for the things that I mentioned before with memory management and the object oriented. They utilize in all of your operating systems as you use is some type of structure that allows them to like really run well. When it comes to set you apart, is that nowadays a lot of people that get into programming, they tend to go for like the much easier or more lenient type of languages when it comes to introduction, like Python or just like scripted languages, because C++ does tend to have a little bit more of a learning curve when you're trying to get into it. But if you get really good at it, then you can pretty much pick up any other programming language, because it will be like a simplified version of what C++ teaches you on how to like think logically. Okay, so thinking logically. In this slide, I have pretty much like divided some of the steps that you should be able to get yourself into doing as you try to code any type of problems. So the main thing is try to make like a flowchart. So with a flowchart, the reason why it helps a lot of programmers is like a visualization of what we need in order to do something, like whether or not the hardware, like the keyboard, the mouse, or anything needs to be inputting any type of information, or if we're retrieving information from like the web or stuff like that. It also helps us to break the mathematical operations of where the block needs to go logically to be able to make like the math be sound. Like you don't want to do maybe like a division before you finish doing some type of summation beforehand. So this helps you like arrange where you want a specific information and when do you want to output it, or if you want to like store it somewhere else and then utilize it a lot later or a lot earlier. So the flowchart and the algorithm go hand in hand. You usually want to know when to start, when to progress, and when to stop it, and what kind of information you printed. Once you have a complete definition or an idea where you want your algorithm to be programmed, then you can go into the IDE and start pretty much like writing your code. And because you already wrote like the step-by-step instructions on how to break your program, then translating into code is actually a lot easier than if you just try to start from scratch. Okay, so now we want to start to code, but beforehand we need to be able to know a bit about data types and variables, because this comes again with the memory management. You don't want to be picking a data type that is too big or too small, or that it won't be properly read. So for these ones, mainly numerical values, we have like the int, which stands for integer, the double, the boolean, and then we have another one that is called float. So each one has like different purposes, and it stores a certain amount of memory within the digits. Like the integers is like for whole numbers, and it has a range of 123 to like negative 123. And then you got the doubles. The doubles is like a bigger version of floating points, which allows you to store decimals and like a bigger range of numbers. And then you have like characters and strings, which allow you to just read like ASCII characters or just text overall. And then your boolean is just like a true or false operators. So we'll be able to dive a little bit deeper into some of those as we try to go. Okay, so arithmetic and logical operators. In here, we pretty much have like your basic math, the way that is structured. So like the plus is addition, we got the minus sign as subtraction, etc. The only difference here is that we have like this modulus, which is used by returning the remainder. This is actually very helpful, especially when you combine it with like Boolean operators, because sometimes you want to keep things pretty simple. For example, like with prime numbers or with like even numbers, instead of trying to come up with like a big mathematical proof for it, you can always assume that a number that has like a modulus of 0 or 1, it will be like an odd or even number. And then you have like your increment and decrement, which is just like a plus plus and a minus minus. This just indicates that increases a variable by 1 or subtracts it or decreases it by 1. And depending on where you put the plus plus, like it can be either in front or after the x, it has like a logical. When it's beforehand is you add the number to x and then you output it, but when it comes to like afterwards, like x plus plus, then you grab in the variable for x and then you add 1 afterwards. We'll run a couple of sample problems that it'll help you like visualize after we're done with this. Okay, the logical operators, again, some of you may be familiar with this. When you highlight like or and greater equal, we utilize those here in code. Again, this will be mainly utilized with like logical statements when you're trying to do like certain type of instructions, like if you want to do this then do that. Then logical operators or comparison operators might be like a good thing to memorize. And then your logicals is like your and, or, and not. Pretty straightforward. It's just comparing certain statements. So when you use your comparison operators and your logical operators, you can get like very powerful set of instructions within your code. Okay, so now we're into the logical statements or the if statements or switch cases. So these are pretty straightforward, logically speaking. An if statement essentially gives you like a condition and you're trying to check on whether it's true or not. And if it checks on whether it's true or not, then you can move on and do an action or a program. In the switch cases, it's just like a much more advanced version of this, where you can get yourself like a menu, and then if you choose a specific condition and it allocates it within true or false, then you can move on and to do like the several actions. Like for these ones, I have a couple of samples that we can look. Okay, so for example in here, I got my integer values, which are x and y, and we're gonna be able to pretty much input any value numbers that are whole numbers. And we got a few like the instructions. The cout is a program to give us a text that is going to be printed out into the terminal here on the right, and the cn is just like it just means that we are going to be inputted the values from our keyboard when we run the program. Okay, so with the if statements, again, I got like an if x is less than y, then we can go ahead and do like operation for a sum, and we add x and y. If y is less than x, then we do a subtraction, and if x is equal to y, then we're gonna do like a multiplication. So every time that we run the code, we're gonna be checking one of these conditions. So if the first one is true, then it only runs the sum and that's it. But if it's not true, then it checks the next one, and if this one is true, then it runs the code and that's it. Then same thing happens at the end. If the first true or false, then it checks onto the last one, and essentially that's what happens. So let's see here, we can run it. Alright, so enter a number for x. So let's try to do the first one. So we give x 5, and then for y we'll do a bigger number, so 7. Okay, and because it's the first option, then it should give us a sum, so it prints out the value 12 right here. If we run the program again, we can do like again 5, and if we do 5, since both of them are equal, it should give us a multiplication at the end. So we print enter, is 25, and it works. So this is basically the logic. Now for switch statements or switch cases, it gets a bit more, not necessarily complicated, it's just a bit more code that you need to write. As I mentioned before, we were doing like some type of like menu input. So in this case, I'm trying to do like some type of calculator where you can do basic operations like sum, subtraction, multiplication, and division. But this time around, it can do it with 3 numbers, and it can be any 3 numbers that I give it. So what the logic does is that once I input my numbers and I'm asking to choose an operation, we're gonna have like an integer that gives us a choice, and the choice is gonna go into the switch statement. So that choice is gonna represent number 1, 2, 3, and 4, which are the numbers equivalent here. And each one is gonna have a specific operation like addition, subtraction, multiplication, division, and then we have a default statement at the end, which it helps us to prevent errors. Like for example, if I were to input a choice number that is not in the range of 1 through 4, like a 5 or a 0, if I mistakenly put like a letter, then it will give us the output of that the choice is not allowed, so we need to like rerun it again. So the switch case is pretty good when it comes to this type of things. So we can go ahead and run the program so we can like see it. Should print. Okay, so it's running. Okay. Okay, so please enter 3 numbers for A, B, and C. So we can do like 25, 30, and 10. Okay, and then we can do like a sum. So we print 1 and enter. It gives us the total. Again, we can do 25, 30, and 10. Well, 10. Then subtraction is negative 15, which makes sense because the operation says A minus B minus C, so it'll be 25 minus 30 minus 10. So we're supposed to get a negative number back. Then you get the idea. Each one, it should work properly, and the range of numbers, it can be whatever you want, as long as it's within the integer variable. So if I want like let's say 500, and then let's say like 20, and then 5, and then we want to like divide it, then it will give us like a total of 5. And then just to double check the default statement that I mentioned before, what it prevents us to put any like wrong input. I can just put like whatever numbers I'm supposed to want, but if I accidentally press like the letter G and I press enter, it tells us that the choice is not allowed, so we got to run the code again and then do any of the choices on that. Okay, so those are the logical statements and the switch cases. Again, we got like the break in the default for it. So now we're gonna go into loops. Loops are incredibly important, not just in C++, but like in coding in general. You're probably gonna be using this quite a lot because it helps you to do like a number of iterations over and over and over again very quickly. So as instead of like the if statements when you're just comparing x and y and do just one specific thing, the loops in here, it can help you do that comparison, and if it takes true, then it can iterate the same operation like multiple times over a certain given amount, whether if you give it the amount or it can just run infinitely. So for this we have like 3 different types of loops, which is like the while loop, the do while, and the for loop. So for the while loop and the do while, they're basically almost equivalent with a bit of just a slight difference. Like for example, the while loop is just a loop that continuously iterates when you give it a specific condition, and if the condition is true, it will just continuously doing it over and over again. The do while is a bit different in the sense that it'll iterate at least once and then check if your condition is true, and as long as the condition keeps on being true, then it'll continuously iterate. But the main difference is that the while loop, it checks the condition before, and the do while is it'll keep doing this and then check if it's true. And then for the for loop, this one you have a little bit more power than with the while loops and do whiles, because you can specifically give the amount of iterations that you want it to do at any given time. It can run it infinitely, but it usually just gives you like more control. And this for loop can be nested, meaning that you can have multiple for loops stacked within each other. That gets a bit more complicated, but if you're interested, you can like play around with it, the logic. For right now, I'm just trying to like introduce you the basic ones to see what they do, and then you can like go ahead and do something with it. So if we go back to the code, let's see. I'm gonna try to run each one. So a while loop. So the logic behind this is my x is equal to 0, so that's like the initial value for x. And the while loop is gonna check that my x is less than 5, and as long as that is true, it's gonna print hello world into the terminal, and afterwards we're gonna increase x by 1, so it'll print hello world, then x is gonna be added by 1, so instead of 0 it's gonna be 1, and then it's gonna go back to the top and then check that 1 is less than 5. If it's true, it prints hello world again, and then it adds 1, making it 2, etc. until this condition is false. Once the condition is false, then it will stop. So for this iteration, it should print hello world 5 times. So let's check for simplicity. There you go, and there you go. So hello world 5 times. Alright, so now we're gonna do the do while, and for this one, again, it's the same iteration. It should print 5 times as well, but the difference is, again, is you're gonna do add 1 to x and then print hello world, and as long as and then check the while that x is less than 5. So as long as this was true, it'll keep iterating again, but even if this was false, it will at least print the hello world once. So like we can run it. Then 1, 2, 3, that's 5, so it's good. Now let's see if it was false. So x is not greater than 5 because it's 0. See, it prints it once because it at least does this operation first, and then it checks whether or not it's true. If it was true, then it will keep doing it until it's no longer true, and because this is false, and it just prints it 1. So that's mainly what a do while makes. Okay, and then for the for loop, which is okay, again we have the x equals 0, but then the for loop, we have an integer called I. This helps us to initiate the for loop, and it's a separate condition than the integer that we give it at the time. These two work together to be able to make the for loop operational. So we're gonna initialize I to 0, and then I is gonna be less than 100, and then the I++ is just gonna keep adding 1 to I until it is 100, and then this condition is gonna be false and it'll stop the for loop. So as long as this is true, then the for loop should iterate 100 times from 0 to 99, and then every single time that it does that, we're gonna have x been adding 5 on each iteration, and then once we get the addition of x plus 5, the new value is gonna get stored into x. So for the next iteration that comes after, that sum is gonna add 5 again. So for example, in the first iteration, you're gonna have 0 plus 5, which is 5. So that 5 will get stored on the x. We print out 5, and then once it checks back to the beginning, it's gonna be true. So we enter the loop, and now x was equal to 5. So we add 5 again, and it's gonna be 10. So 10 will get stored into x, print out 10, and we're gonna keep doing this until the iteration is false. So this is the logic of it. By this logic, we should be printing a series of 5 plus 5 all the way to 500, because it keeps doing it 100 times on that end. So we check. Then yeah, so up to 500, And if we see here, yeah, it starts at 5, and then it keeps on adding 5, 15, 20, and it's like a whole series, and it repeats itself 100 times until we hit 500. Alright, okay, and then lastly, we're gonna talk about arrays. Okay, so an array is essentially a way to store multiple values within one single variable. So far you've seen me do like X and Y, and it can be like any other variable. You can do like ABC or use words to make your variables have like a specific value, but they're always gonna be fixed to one value unless you do like extra operations that we did in the for loop, where you have to like change the value of the variable by utilizing that same variable and adding or subtracting and doing some specific changes. So with arrays, you can just use one variable and then store multiple values in it. And it can also work with strings and characters, like with words. It doesn't have to be just numbers. One thing that we need to remember is that computers always start counting from 0. So it's gonna be always from 0, 1, 2, 3, unless you do a specific instruction where you add 1 at the beginning and then it counts from 1 to etc. But you usually don't do this, so always remember that you start counting from 0. So in the string cars, the 4 here, that just means that the size of this array or the amount of variables that it can hold is 4. But if you want to start counting it, this is going to be like variable 0, variable 1, variable 2, and 3. So 0 to 3, and it is a value of 4. It is very powerful because if you're thinking like a mathematical way, something that we can utilize in here, it could be like matrices. And you see how like matrices are just like an array of numbers within the boxes, and you want to probably like do certain multiplications or additions or things like that. Arrays are very helpful with that kind of application. And if you pair it with a for loop, then it becomes like a very powerful tool to do this. They take a bit of time to get used to it, just because of the amount of things that you can actually do. But if you don't work your logic properly, then you can get mixed with some of the things. So for the sake of that, I will not be doing like an overly complicated array example. The best thing that I have at the moment is just pairing it up with like a for loop. So I made like a prime array, which is store the first 5 values of prime numbers, so 2, 3, 5, 7, and 11, and then I have a for loop that is gonna iterate every single value within that and then print it out. So as long as my I is less than the amount that it can hold in here, and it keeps iterating, it should print pretty much all the values inside here. Yeah, so 2, 3, 5, 7, 11. And then if you want to skip every one, so like 0 to 4, yeah, 0 to 4, then you can do like a 9 plus plus in here, which is gonna be adding 1 to the value, so it'll start at 0, but then once you print it, it moves to 1, but because you're adding the 1 afterwards, it actually skips the 3 and it'll move to the next box. So in this case, it'll print out just 3 of the values, which is 2, 5, and 11, as we can see here. Okay, that's all I have for you guys today. I don't want it to go way longer than what it needs to be. If this catches your interest, like if you're a complete new to programming and you think that this is something that you might want to pursue further, you can come to the TTP Center. My name is Diego. I think I forgot to say that at the beginning, but I'm the CS mentor for it, and you don't have to just be CS because a lot of the CS people will probably already know all of this. But for anybody who's just want to pick up programming or is interested in taking some of the CS courses within UCR, UCR, the entire catalog is built between C++. So this is like very helpful for an introduction. And you might want to do like a course for fun, or you might want to do like a minor, or you're thinking about like just trying it out to see if it might be like a different type of career path that you want to do. Then you're always welcome to come and talk to me, and I can direct you into like other ways to practice and more things to learn, and I can just help you out through your entire journey with programming. And if C++ is a little bit intimidating, or there's a lot of questions that you might have, I can answer them, and if not, I can always introduce you to like a simpler language that you might want to utilize, and I give or take. I just think it's like a very important skill nowadays for all engineers to know a little bit of programming, just because a lot of the things are moving into computers. But anyway, other than that, thank you so much for being here, and I'll catch you guys later.